Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes to us from Roberto, N9NUQ. And he has a question about why suddenly his SWR is changing in real time. And so this might be a real interesting one to explore. He says, I have, he has Videographed equipment, including the 500 watt amplifier. And his antenna is a Force 12, which is, they're kind of not really doing much right now, but for a while they were, to make a pun, a force in Yagi antennas. They made some very strong stuff. He has an 8-element model C4E. He had a balun. Now, the Force 12 antenna, I believe, has a balanced feed. So you need something to convert the balanced to unbalanced up there when you send your coax up. It could be as simple as a series of ferrite beads around the antenna, which is an easy way to do it. Another is a loop of, say, 8 or 9 turns, 9 to 12 inches in diameter, just looped right there. The inductance that it encounters as it goes around will act as a high impedance to the common mode current coming down the outside of the coax. You can also just put in a store-bought 1-to-1 balun. Okay. Now, he says the balun I was using is 12 inches long. That means that it was a balun very similar to this one. This one right here is the MFJ 915. Okay, and it is between here and here. I think the thing makes a loop like this. There are a gazillion ferrite beads around the coax to keep anything that's on the outside of the coax off of it. Okay, and it says RF isolator. It functions as a balun. Okay. Balanced to unbalanced feed, although it's not a transformer. But you can also put a transformer balun in there. They're made by lots of people in Balun Designs, where he got his, is one of the most reputable balun makers that we have in ham radio. He says, while transmitting with the app on, I noticed that my SWR was going up. Now, I'm going to think that this is due to heating of those little beads in there. They do have to dissipate some heat. Not all the heat, but some of the heat. And if that was happening, you could be losing the effectiveness of the balun. The SWR was going up. Another thing that can do it is heating in the coax. If the coax has water in it or something like that, it could be causing a problem. Okay, I went ahead and purchased a new balun. Okay, 1.5 to 54, a 5 kilowatt version from Balun Designs. But when I raise up the antenna up to 45 feet, the SWR goes up. It sounds like it goes up and stays up. It's not a heating issue at this point. The SWR shot up, and it's 14 on 20 meters, and it's 9.4 on 15 meters, and it's 8.8 on 10 meters, which are utterly unacceptable values. You're not going to get anything out of that. Hope you can tell me what to do or buy. By the way, I do remember in 1994 that I made an RF choke by making 8 turns of about 10 inches in diameter. I might still have that in the garage. Yes, that definitely would work. So before we jump into Roberto's answer here, I want to pay a special thank you to Rick Corona, who just became a patron of mine. And what that means is he's gone to patreon.com/KE0OG and selected a support method that works for him. You can do the same. Now, let's jump into Roberto's question. Okay, let's take a look at what's going on here. Now, I can't troubleshoot his problem directly. Now, he has Videographed and it's a K4D. And it goes to the KPA 500, which is a 500 watt amplifier, very similar to mine in terms of capability. Okay, and this goes out to a Force 12 Yagi, okay, with a bunch of elements up here, and I guess this would be the driven element. It would go to that, okay. Now there are multiple ways to feed a Yagi. You can do a feed called a, let's see, I think it's called a gamma match. And the way that works is you've got your driven element. This is the center. You attach this to the coax shield, and then there is a small tubular capacitor here, and it connects over here, and this is the inner conductor from the coax. And you can adjust that capacitance. It's actually just a little sleeve made of aluminum with a center post going into it and a piece of polyethylene around this, and you adjust how much it goes in or out to adjust the balance on that. I don't know what the delta match, or I don't know what the match is here. It might be a different kind of a match. There's another match where you can come up over here and feed over here too. So there are many, many, many different ways of feeding Yagis. Okay, so what can go wrong? Well, as you know, the first rule in antennas is that everything affects everything. Okay, so we've got our reflector, our driven element, and our directors right here. And we've got coax. Now, you need the equivalent, something that changes the balanced of the antenna to the unbalanced of the coax. Coax is by nature an unbalanced medium. And most people like to feed their antennas with coax. This thing turns all the way around. It's very difficult to feed with open wire line. Okay, so, and besides which there'd be an impedance mismatch unless you reset the match that's right there. Okay, so what you are trying to do, and I'll just illustrate this with a single antenna element, okay. What you are trying to do, we'll just use a dipole, okay. And we've got feed down here, and we'll make this coax, okay. So you're feeding the one side with the center, the other side with the braid, which is a time-honored way of feeding coax. Now the problem is you've got energy coming up inside the coax, and it'll go out there, and you've got the return, which is the inside of the shield, goes out there. Okay, but the way you connect it, you just take the shield, wrap it around here. There's no way at this point at the top of the coax of keeping that from contacting the outside of the shield. You say, well, good grief, it's one wire, you know, it's a shield. Well, at DC that's true, but at RF, the RF tends to travel on the surface. So it travels on the inside surface of the coax. Now, you're going to get reflections. Unless you have one-to-one SWR, you're going to get reflections. And even if you use this without a balun, you're going to get reflections. And those come down the outside of the coax. Okay. It's almost as though coax were a three-cable conductor. You've got the inner going to there, the inside of the shield going to there, and then the outside of the shield conducts RF away from the antenna. And you can see where this could affect the SWR, because this not being balanced, it's all on one side, this radiates just like an antenna. Now, to fix this, we want to put right here something that is a high impedance. Okay, a high impedance to anything coming this way to stop it from going further. And you want to put it right up there as close to the feed as you can get it. Okay, like right at the feed. Now you've got several options. You've got a 1-to-1 balun. Very often a choke balun is used in this case, but you can, well, I'll talk about different types of balun. A 1-to-1 transformer balun. So you have windings around a common core, and this is usually a ferrite. And then you have more windings around the same core, same number of windings, so it's 1-to-1. Now, actually, the balun ratio is the square of the turns ratio. So if it's 1-to-1, it's 1 squared, which equals 1. Okay, you can put that up there. Now, what that will do is any energy that comes down here as a common mode that wants to come on both sides. This is a little bit different now. If you get energy wanting to come down the center and down the shield that are in common, you've got this, and a coil in between. And so anything going here comes in this way, cancels each other very nicely. So you won't get anything going down this way. So another thing you can do is ferrite beads. And you can put them around this, you know, put 8 or 10 or 15 or 20 or something like that. You can buy ferrite beads on Amazon very easily. Just look up ferrite beads and find ones that you like. Or you can call your big houses like DX Engineering or Ham Radio Outlet and ask them. I might start with DX Engineering. They are really into antennas there, and they can give you a very good idea of what to put in that. Obviously, you put the beads on the coax before you either attach a connector or connect it directly to the antenna. Now, what happens with the beads is that the beads are ferrite. Okay, they're ferrite, which is powdered iron mixed in with the binder. And what you find is that the signal that tries to come through sees that as high impedance and is blocked. One ferrite bead won't do it. You'll need multiple ferrite beads. The other thing that you can do is take a fairly large toroid and wind your coax through it like this several times. The direction doesn't matter. Okay, so you have one coming out here and one coming out here. That will also work as well. Now, the problem is that each turn in the ferrite attenuates the incoming signal a little bit, but not completely, and that's why it takes so many of them. This leaves these beads subject to heating. Now, the idea is overall to present a high impedance. If there's a high impedance, there's not going to be heating. Okay, and you're in good shape. Okay, now, so you can do the ferrite beads, you can do the 1-to-1 balun transformer, you can also do a loop of coax like this, about 9 to 10 turns, about 10 to 12 inches. what happens here is that the signal that's going down the outside encounters this impedance made up of the outsides of the shields of the coax cable. And because it encounters a high impedance, you don't get so much coming down to the antenna, okay? Or to the radio. This goes to the radio. This goes to the antenna. All right, so you've got options like this. The other option, of course, is to just connect the coax straight like that. And if you don't get any RF in the shack, just leave it. But that leaves purists sort of in a terrible nervous state when you do something like that. I'm going to suggest that you go back to the manual for the Force 12 antenna. They used to be up here in Grand Junction, north of us, but they're not there anymore. The Force 12 antenna, go to the manual and see exactly how it says to feed it. Now, even if you feed it with RG8X, which you certainly can do, it'll handle all that 500 watts. If you want to get up into the 1.5 kilowatts, I suggest going for either RG213 or LMR400. The 400 is harder to deal with normal tools, but with the proper tools that you can get from Times Microwave, they've got a very, very nice and easy to mount connector for these. It's actually quite innovative, I think. It's all crimp connector. These you can do your standard where you crimp the exterior and solder the interior. And make sure whatever you do up here, it's well waterproofed. Coax cable has that braided shield, and it acts like a wick. And just wick water into the cable, which will eventually corrode the cable. Okay. All right, so there's the problem. Now let's talk a little bit about what might be causing the heating or causing the SWR to change. Obviously, something happened. To get a high SWR like that, it almost sounds as though the cable broke, or the cable partially pulled out of a connector, or something like that. So you're going to need to do continuity tests on the cable. I even have this little device right here, which is a light and then an SO239. So you can put this on the end of your cable, put 12 volts on the other end, and see what happens to the light. The light should come on. If it does not come on, you've got either an open or short in the cable. Now, an open or a short in the cable will obviously make the SWR reading go haywire. It will not necessarily be infinite SWR, however, because the cable is long enough that there is absorption of energy. There's heating in the cable. And that can cause it to appear to be a lower SWR, although not that I'd call 14-to-1 a low SWR. That's an unbelievably high SWR. You don't want it to do that. So, break in the cable, look especially at the connectors. If the connectors are crimp connectors, use a trick that I put in Ask Dave some time ago, where you take a pair of pliers and you know where the cable comes over the center conductor, there's supposed to be a ring there. Just use your pliers to squash that ring, and oftentimes that will restore it. But make sure it's thoroughly waterproofed after you are done with it. So an open or a closed cable of a length needed to reach a tower could cause that problem. Okay, other things that could cause the problem is that the extra power is causing heating in your ferrite beads. That would surprise me a little bit, but it can happen, especially if they're small. I'd go ahead and get the larger balun so that you can wrap the cable through it several times, okay? Or use that coiled up cable like you were talking there before. That would do it too. Inspect the one-to-one balun. There's a difference between a current and a voltage balun. A current balun will take two, and I suspect that there's just one in the balun designs. It's at the center point, so it really shouldn't matter. You've got equal voltage on both sides, and that's what you want for a center-fed driven element. Okay? So, after reading the manual, checking inside the balun just to make sure that nothing is loose. I mean, balun designs make some really incredibly sturdy baluns, but, you know, anything's possible. The ferrite beads could be overheating, so replace that section perhaps with, you'd need bigger ferrite beads that could dissipate more energy. But again, the point of that is to present a high impedance rather than a load impedance. A load impedance would cause it to dissipate a bunch of energy. So something is changing. Something happened while you made the transition. In general, troubleshooting procedure, you look for a single fault first. And the first thing you ask is, what changed? Well, what changed was the balun, okay? So we're going to look there. Look at the connections on either side of that and make sure that they are good connections. Make a little lamp like I did or something like that, and make sure that all of your pieces of cable are correctly done. The next thing you do, and you may or may not want to haul this to the top of the tower, is a dummy load. This is my dummy load. It's an old Heathkit antenna. It will dissipate 1,000 watts for up to 5 minutes. But that's not really what you're looking for. Attach the cable from that would normally go into the antenna, put it into the dummy load. Then go back to your station. You should measure 1-to-1 SWR across the bands with the dummy load. Okay? Now, if you don't want to haul something like that, and you just want to use like an antenna analyzer, like one of these that I've got over here, you can just put an ordinary 50 ohm resistor across the end and test it with one of those. And it will tell you if the SWR is not 1-to-1, there's an issue. So something failed, probably one thing. You not only took the antenna down, but you made two changes. You've changed some cables there a little bit. So that's two changes. Start for the one change, then look for two changes. Anything, you should find it. With 99% of the time, you'll find the problem in those two changes. Okay? So I hope that helps, and I tried to broaden this question a little bit, Roberto, so that it would give a little bit more of a broad overview of some ways to troubleshoot antennas and so on, where we're dealing with balance and that sort of thing. So there you have it. If you would like to help support this channel financially, you certainly may do so. Go to dcasler.com/support and look for a way there that works for you. And until we next meet, 73.